So let's start. We're going to do question 5 on the 6.2 proportions homework. So let me pull that up here. Let's pull that up. I hope you guys are all having a lovely day. It's a nice Tuesday. It's a little bit rainy, but it's not so bad. It's comfortable, in my opinion. As I buy time to get into that specific problem you have. And MyLabs Plus likes to be a little finicky right now. It just said we can't access that course. And I said, you know what, MyLabs Plus? I don't appreciate that. And I'm just going to try again. Why I had to cross multiply rather than multiply everything by the LCD. Very good, not a problem. So, I mean, maybe I can just answer your question out there. It's just 6 of one, half dozen of another. If you get the right answer on the homework or on the exam, and I look at your work and you used a good process, I don't really care how you did it. As long as you just didn't get lucky, basically. So if you want to try cross multiplying, which makes our lives a little bit simpler because it helps us to simplify fractions before we really have to jump in and do anything with them. So that's just one way to think about it. So maybe I'll make a little text box here. Cross multiplying versus multiplying both sides by the LCD. Yeah, so it's whatever your flavor is, in my opinion. Especially on the exam. Like I said, if you use a good process and you get the work done, you get the right answer, I ain't gonna worry about it. You're good to go. You got the right answer. So yeah, and so Xavier, you were asking me this. Did the online homework, when you said, "Hey, how do I solve this?" Did it like show you to cross multiply? Did it say, "Hey, you should cross multiply"? Whereas in class we talked about maybe multiplying by the LCD. Is that kind of where the confusion is? Yeah. So then, yeah, that's just because that's just the method the homework decided to show you. 6 of one, half dozen of another. You can use a method that is comfortable for you. So does that answer your question, good sir? Cool, awesome. 6.4, number 22, very good. Let's go pull that up real quick. 6.4, number 22, 6.4, number 22. All right, so I've got it pulled up. Madeline is asking about this one. So it says, the bar graph shows the percentage of households in 1988 and 2008 with an interfaith marriage, and the percentage of household in which a person of faith is married to someone with no religion. So let me go ahead and just share that screen with you. There we go. Do you see what I see? Now you do indeed. So yes, we're talking about interfaith marriage, which is people who are of different faiths marrying together. Yeah, this one looks like it's a little bit of an ugly one. So we have two bar graphs. Unfortunately, it's hard to see all in one go, and they don't like to make it user friendly here. So maybe, no, it's just, you can only zoom in. So let's see what's going on here. The percentage of households in an interfaith marriage is given here. In the darker orange, that's saying for the year 19, that might be an issue. It's saying 1998 here, but I'm sure they mean 1988. So it's showing, so we'll assume that the dark orange is for 1988. So 51% of people, of marriages, were in an interfaith marriage in 1988. Then in the more cream color, the lighter orange, 56% of marriages in 2008 were interfaith. So I'm guessing that means one person could have been Christian, the other person could have been Buddhist or whatever. So then In this side over here, you've got faith/no religion. What that means is that one person is of a faith, the other person is an atheist or something like that. They have no religion. And in 1998, 1988, 31% of marriages would have had that kind of setup. 36% of marriages would have had that set up in 2008. So let's see, the formula I equals 1/4 x plus 51 models the percentage of households with an interfaith marriage, I, X years after 1988. The formula N equals 1/4 x plus 31 models the percentage of household in which a person of faith is married to someone with no religion so many years after 1988. Use the models to compare parts A and C below. In which years will more than 58% of households have an interfaith marriage? So this one, what we're going to have to say is, let's see, we're talking about interfaith marriage, so we're using this formula, the I equals 1/4 x plus 51. So maybe I can just write on the screen directly here. I'll use red. So we've got I equals 1/4 x plus 51. So what's happening here? This is a line with a positive slope, 1/4. So as I increase the number of years since 1988, as I increase x, then there's going to be more and more people entering into interfaith marriages. So what I need to do is I need to set this equation equal to the 58% I'm curious about. Now this is already as a percent, so I don't need to do any weird conversions. I just need to set 1/4 x plus 51 equal to 58. And I need to figure out what x value, where x is the number of years since 1988. I need to figure out what x value will make this a true statement. Does that make sense out there? Does that make sense? Good. Yeah, so we're trying to, because this thing, I plug in an x value. So if I plugged x equals 20 in, 20 would be 20 years after 1988, which would be the year 2008. Okay, very good. So it's kind of making sense. So we need to solve this. Very good. For x, because as it is written, x I'm going to give it to you. Not the first time nor the last time I'll make that joke. So we get 1/4 x equals 7. And Xavier is x in this particular situation. So this is, I didn't realize you were the rapper Exhibit. It's not Exhibit, is it? No, it's DMX, never mind. Yeah, I make that joke too a lot. It's, it's fun. So now you have 1/4 x equals 7. We want to get rid of the 1/4, so you can either divide by 1/4, but that's the same as multiplying both sides by 4. And so indeed, x is going to give it to you, x being 28. So starting 28 years after 1988, you're going to have at least 58% of households engaged in an interfaith marriage. And then as you go beyond 28 years after 1988, it's only going to go up because the slope was positive. It's only increasing over time. So 28 years after 1988, so we need to do 1988. It's a bad 9. Well, this is one I would do in my head as 2016. So starting in 2016, you'll have exactly 58% of households in an interfaith marriage. And then for 2017, 2018, 2019, it's only going up and up. Does that make sense, my friends? If not, you are certainly free to ask. Yes, sir. Please ask if you need any clarifying on that. Now, I would gamble that the rest of the problems will look like that. So do we want to keep doing the parts B and maybe C here for this one, or do you think you can kind of reverse engineer it from here? Okay, we will continue to do that. So that would be, we got 2016. So let's try that out. All years after what, 2016? Let's see if it likes that. Hey, it liked it. Now part B wants to know, starting with what year and everything beyond that, more than 44% of households will have a person of faith married to someone with no religion. So basically, another way we can do that. So now we want to use the 1/4 x plus 31 because that is the formula for the person of faith with a person who does not have faith in that particular case. Now I just realized this is the linear inequalities section. So in part A, I used an equation and my reasoning was still perfectly valid, but this time we'll write it using an inequality just to make it happy. We'll tickle it a little bit. So we'll use the 1/4 x plus 31. Now, and we want to know, when will this quantity be greater than or equal to 44%? And again, it says percent, but everything's already as a percent. So there's no weird decimal conversions you have to worry about in this particular problem. Let me just slam my Monster Energy drink. Okay, so now we just have to solve this. So last time we made it an equation. This time we're making it an inequality. It's semantics. As long as you realize what's kind of going on, you don't necessarily have to recognize it as an inequality. But I guess it doesn't hurt. So now we got to solve for x. So now it's 1/4 x greater than or equal to 44 minus 31. Do a little quick math. Do it in my head maybe. 13. Of course, you can do the old school subtraction. 4 minus 1 is 3. 4 minus 3 is 1. You'd have 13. And now we would then have to say, okay, we need to solve for x. Last time we multiplied both sides by 4. 4 is not a negative number. So we did not have to switch the sign on the inequality. Don't worry about that. We'll just get x by itself. X greater than or equal to 13 times 4 will, let's try it out up here. 12, carry the 1, 4 times 1, plus 1, 52. So 52 years after 1988, and then for every year beyond that, the number of people who are going to be in a marriage where one person has faith, the other does not have faith, it's going to be 44%. So we need to take 1988, which is 1 year before the year I was born. Random trivia. Will that be on the test? Probably not, because it's not all that interesting. But it is the truth. 1 year before the year I was born. Most of my friends were born in 1988. So it looks like that's going to be the year 2040. The year 2040. So starting with 2040 and then beyond, you're going to see at least 44% of marriages be one person have faith, the other person not. So 2040, and it's going to be after. And let's try it out. Yay. And then part C. Part C is a clever one. Based on your answers to part A and B, in which years will more than 58% of households have an interfaith marriage and more than 44% of households have a faith/no religion marriage? Well, this one's actually tricky. What year? So it has to satisfy both criteria. Only in the years after 2016 will this criteria be true, that at least 58% of households will have an interfaith marriage. But only after the year 2040 will this criterion can be true. We want both criterion to be true. That word and gives it away. We want both the first thing and the second thing. The only way that's possible is if you go after the year 2040. Because if you're after the year 2040, you satisfy B, and you've already satisfied A years earlier. In fact, that is a great way to introduce the idea of set theory. Which we will talk about in detail in chapter 2, of the next course, of the 1332 course we'll be starting up here in a few weeks. So that's a great kind of introduction into that. That is the intersection concept. All right, friends, I'm open for a new one. Madeline, did that one make sense? Good, good. Gabriella, I mean, are we going to have questions like this on the exam? I mean, technically it's possible. I don't foresee this exact type of problem, but this is certainly a possibility. Always. Technically, everything we cover could be fair game, but I do kind of zone in a little bit more on the things I covered in class specifically versus things you might see on the homework. The homework is just to kind of give you a wider perspective of things, but it's not necessarily the end all be all. Question 17 on section 6.3. Let's pop it open. Let me stop sharing for a moment. Be gone, I say. Let's open that one up. (17) on section 6.3. Ooh, a fun one. So very good. Does this one look like what you have, Xavier? X-Man. I think, does that one look roughly? Or if you just want to, Xavier, if you just want to share the equation you have on your version of it and tell me which variable to solve for. Madeline asks, do we need to get our tutorial hours before the first 8 weeks, or do we have this whole semester? That's a great question, Madeline. The tutorial hours, the 12 hours you need in order to satisfy 5% of your final grade. You don't have to have it, but that 5% can usually be the difference between passing and failing if you're on the edge. You will need to get those 12 hours done before we take our final exam for this first half course. So in other words, yeah, before the first 8 weeks are up. Now remember, at the moment, I'm planning for us to take our final exam on October the 8th. So you have a little more than 2 weeks now to get that done. So good question. So yeah, remember, you got to get those tutorial hours done. What's the best, easiest way to get those tutorial hours done? Well, you can go to the Academic Support Center, but remember, they're doing by appointment only. You can use tutor.com, but you kind of have to set that up with the Academic Support Center to get that exactly where you want it. But ultimately, you can go to the study plan in MyLabs Plus. If you click on the study plan, you can find all kinds of extra resources. And if you're working practice problems and practice quizzes they have in there, then it counts your time, and I can go see how much time you've spent in there. So that's probably the easiest way for you to rack up your stuff. Okay, so Xavier, you got one about sales tax. All right, give me 1 second and I'll try to pull up one that looks similar to yours. No worries. So for me, that's just number 15 on that one, but that's not a problem. Ah, this one's going to be an interesting one. Including a 9% sales tax and inn charges $215.82 per night. Find the inn's nightly cost before tax is added. Ooh, everyone out there say, ooh. Will, did we get some ooze? I got some ooze, all right. Um, Teenage Mutant Ninja Turtles 2, Secret of the Ooze. The first Mighty Morphin Power Rangers movie, the bad guy was named Ivan Ooze. So this is very important history that we're learning here. So here's what's happening with this one. Let's think. So what we're looking for, we're going to call X. And X is going to represent the cost, the nightly cost, whatever, the cost before sales tax is applied. Cost before sales tax is applied. So what we would do is we would have an equation that's going to look like this. Let's say to find what we need, X is going to be that cost. Now, if I take the cost and I add on 9% to it, it comes out to 215.82. So I need to add on 9%, but 9% of what? Well, so I'll write 9% as a decimal. I take 9% of that base cost. You can call it the base cost or the pre-tax cost. I add 9% of itself onto itself, and that will give me 215.82. Does that make sense, Xavier? Does this setup? Very good. So this setup makes sense. Now I need to actually solve this for X. I'm going to combine like terms. Remember, there's secretly a 1 in front of X here. So when I combine like terms, I'm doing 1 plus 0.09. So I get 1.09 X equals 215.82. So far, so good, Xavier? Good, good. Now, in order to solve for X, well, the only thing that is plaguing X right now is that it is being multiplied by 1.09. So I need to divide. And then, yeah, it's relatively simple. It's still going to be kind of an ugly long division problem. It's going to be a not so pretty long division problem. Are you comfortable doing the long division from here, or do y'all want me to do the long division with you just so you have another example to check out long division? You got it? All right. Does anyone else want me to just finish it off? It's no worries either way. But yeah, you need to do 1.09. So it would look kind of like this. All good? All right. I'll just set it up for you real quick and then we'll move on. And I won't actually work it. We would be dividing 215.82 by 1.09. Remember, you would move the decimal place 2 places here because your divisor needs to not have a decimal. But for every place you moved it in the divisor, you move it as well in the dividend, it's called. So it's the same as dividing 109 into 21,582. And so you just have to take it kind of slowly. The numbers might look bad, but I'll give you a hint on this one. The number comes out clean. It comes out with no remainder or any other business like that. It's a nice clean cut. So that's how we can work that one. Okay, who else has something for me? Give me something. Tell me something good. Bam, bam, bam. Not gonna sing. What else do you guys got? I can also, if you guys don't have any more problems, you want me to work from the homework, I can kind of just give you some basic stuff, some good review stuff that we can talk about. So it's really, I mean, this time is basically your guys' time. A lot of trouble with 6.3.31. All right, give me one moment. I can take a look at that. All righty. Does this look correct, Xavier? Looks like what you want to do. All right. So again, we talked about those general strategies for solving applications problems. And that's what this is, applications problems. For us, is a fancy way of saying word problems. So let's just try reading it, see if we can make sense of what's going on here. The bus fare in a city is $1.50. People who use the bus have the option of purchasing a monthly coupon book for $29. With the coupon book, the fare is reduced to 50 cents. Determine the number of times in a month the bus must be used so that the total monthly cost without the coupon book is the same as the total monthly cost with the coupon book. All right, very good, very good. So let's establish a few things here. Again, the usual strategy we're going to have to use, we're going to have a variable. I mean, that's kind of, it's math class, we're solving equations. So I'm going to let x be my variable, but I can make it whatever I wanted. I could use a lowercase f and f for fare if I wanted. Just how you're feeling at that particular moment. So we're going to let x be the number of times, I'm going to extend my text box here, the number of times you have to, I do not like that. You do what I tell you and not lick more. It's the number of times you have to ride the bus until both methods cost the same. So there's going to be two methods here. We'll call it method A. Method A is just, it charges you $1.50 every time you ride the bus. So the total cost, because we're gonna compare total cost. The total cost of method A, that's gonna be based on how many times you ride the bus and the charge per time you ride the bus. So that's $1.50. Well, for our sakes, you can leave the decimal point off, or excuse me, you can leave the zero off here, because 1.5 and 1.50 are the exact same thing. It's going to be 1.5x. That's it. And it deleted my text box, but total cost of method A is 1.5x. The total cost of method B, now it's a little bit different. This is a lot like that problem we did last time we met, where we compared what? We compared text message plans. This must have been 2005 because you don't pay per text anymore. But we compared text message plans and we said, how many texts would you have to send until the two plans are of the same cost? So the total cost of method A is 1.5x. The total cost of method B, well, we're going to be spending 0.5 of a dollar or 50 cents per dollar, but I don't need that zero at the end, for every time I ride the bus, which is what x is. X is the number of times I'm going to ride the bus. Plus, I got to charge 29 American dollars. That's a flat fee I pay. So this plan is for like people who ride the bus a lot. If you plan on riding the bus a lot in a month, maybe you ride it twice a day to work and back, then you probably are going to end up wanting plan B. If you're just a tourist visiting and you're only going to ride the bus 3 or 4 times throughout your entire trip, you probably want method A. What we're doing is figuring out the exact number of times until both methods are the same. And then if you ride the bus more than that, you want method B here. If you ride the bus less than that, you want method A. And now we want to know how many times you have to ride it until the costs are the same. Since this represents the cost of method A, this represents the cost of method B, we just need to set them equal to each other. Make a little sound effect. And there you go. That's going to be our procedure. It makes sense. So now we just got to solve that bad boy. Does it make sense up to this point, guys, my friends? Let me know. I don't want to lose anyone or go too fast or miss out why we're doing what we're doing up to this point. So I'll answer your question, Nicole, and then after we finish this one off. So now I need to subtract 0.5 from both sides, 0.5x, I should say. Well, that's going to make this one just an x, a 1x, if you will, on the left-hand side, but that's just x. And on the right, it's 29. And guess what? This one's, it just went down. That's all we had to do. We already got x by itself now, by coincidence. Usually that's not how it works, but that's just how it happened in this one. So 29 times, if I ride the bus 29 times, method A and method B will cost me the exact same. But if I plan to ride it more than 29 times, I should use this because the 0.5, now it's going to cost less from that point on per each time I ride. But if I ride less than 29 times, I should use this one. So 29. Okay, on 6.25, number 8, mixed numbers as decimals. The answer is 1.667. I'm a little confused when we should use the number with the line above, okay? So let's see what's going on here. So Nicole, I'm guessing, so 1.66667 is the same as the fraction of 5/3. I'm assuming that you rounded that. Because 5/3, well, you don't have to believe me. We'll do the long division. 3 goes into 5 once, and now I'm going to give myself some decimals. And I'm going to give myself some zeros to continue this on. 3 goes into 26 times. Uh-oh, if I keep giving myself the zeros I need, 3 goes into 20 again 6 times. And you can see that I'm just going to repeat this pattern. Oops. And it's just always going to just give me 20s again. So 5/3 is really equal to 1.666. I'll do one more 6 because 3 6s is uncomfortable. ... So what you can do, let's say if a problem said round to, I don't know, round to 3 decimal places. Well, here's the 3rd decimal point. We look 1 over to the right. That's a number that's 5 or greater. So we're going to round this up to 1.667. And we can say we're done with it. That's if we want to round. Remember, rounding inherently means we're going to have to, it's not going to be exactly the same answer. This right here is not exactly the same as this. They're off by a little bit. The further out you decide to round, the more decimal places you just decide to round, the more accurate this is to the original answer. But no matter what, if you're rounding, you don't have the original answer. You're not the same. But this is good enough. But just remember, you can write 1.666666. Since the 6s are just repeating forever and ever, you can just write it as 1.6, and then you can put the bar over it. And now, this was not rounding. We did not round when we did this. We simply re-expressed this exact same number here in a shorter way, but we didn't actually round it. 1.6 with the bar over the 6 is exactly equal to 1.666666666. This is just like a shorthand way of writing it. Whereas this, when we rounded, we technically changed the numbers slightly, very slightly. Does that make sense, Nicole? Very good. So it just depends on context. You're welcome. It just depends on what you have. If the problem says to round, round. If it says leave it as a fraction, you can leave it as 5/3. Usually when you have your answer is a fraction, you want to put it in lowest form. So 10 over 6 is not in lowest form because 10 over 6 could reduce to 5/3. Let us take attendance real quick. Let's take some attendance. I'll pause the recording, so watching it later, you won't see this part. So once again, I think some people weren't quite here at the beginning. I'll go over just real quick our procedure for exam 2. Remember, exam 2, you're going to be taking it on Canvas. You'll see an exam 2 module that will be opening up on Canvas on when you can. The exam will open at 12:05 a.m. Thursday, so just a little bit past midnight, and that just clears up any confusion, because if I say midnight Thursday, it's like midnight the day before. No, 12:05 a.m. Thursday, and it closes 11:55 p.m. on the same day. So you have 24 hours minus 10 minutes. So you basically have the whole day to take it. And that's just to clear up confusion. Remember, you want to submit your scratch work within 30 minutes of completing your exam. The scratch work thing, you'll see it when you take your exam. You'll see it's just below it. It's very straightforward. You can upload pictures of your scratch work. Make sure it's nice and neat and everything's ordered and clean and happy. What else? You can do multiple submissions of your scratch work. If you submit something you don't like it, just submit it again. It'll let you, and I'll just grade your most recent one. Remember, your third exam is technically next week. So you're like, Josh, I hate you. You gave us multiple exams in a row. But remember, that third exam is really just, it's almost like a bonus. It's not a bonus, but it's almost like an extra assignment, because it's what I call a self-paced exam. It's just going to be an assignment you see opening up in MyLabs Plus. It's very straightforward. It'll count as an exam. It won't quite be as lenient as a homework assignment would, but you can take it whenever you want throughout the week. You can open it and close it multiple times. So it's just kind of, it's like round robin. You can go in whenever you need to. You don't have to take it all in one sitting. Each problem I'm going to allow for 3 submissions on. So you have 3 chances to get it right. And if you don't get it right after 3, you will be counted wrong. So it's like a hybrid between a true exam and a homework assignment. It will only cover material since the end of the material that exam 2 covers, and you have the whole week. You'll have all of Monday through Friday to take it. So it's a lot more liberal than a normal exam. And and the trade-off is that you're going to have, looks like, less total homework due next Thursday. So then you'll have that exam. So it's pretty straightforward. I'll give you more details about that. I'll send out an announcement this Friday for it. But it's a lot less stressful than a regular exam will be. And that's just because our schedule is kind of wonky this semester. We just don't have a ton of material to cover in this developmental portion of the class. To be completely honest, we don't. And so I was able to basically cut this down to 7 weeks, and then it will give us 8 or 9 weeks for the 1332 portion of the class, which is where things get a lot more interesting. They really do. So yeah, that's kind of how it's going to go. So exam 2 is this week, exam 3 is next week. It's already been brought up that you do have your tutorial hours. You need to have 12 in by the end of the semester. The easiest way to do that is to do 12 hours worth of work in the study plan. And that's going to be that. Do you guys have any other questions for me? This is just review day for exam 2. Are you guys all able to see, just the announcements that I send out? Announcements that I send out on Canvas just show up. Good. Yeah, that's a good way for me to kind of get information out to you. A good overview. So we want to take a quick overview of what this is going to cover, of what exam 2 doth cover here. So it covers sections 6.2, 6.3, and 6.4, which doesn't sound like a lot. It doesn't cover anything from chapter 7. That homework's not even due till next week. So don't worry about chapter 7 material for exam 2. Really, some of the biggest problems I'm going to be going over are solving linear equations and solving linear inequalities. And we've already done examples of both today. So some of the major concepts, I'll go through it here with you. Some of the major concepts for exam 2. Solving linear equations. And we've already seen a couple examples of those today. But, you know, an example of that could be, and I'm just going to make one up here. That's a linear equation. I know it's linear, even though it doesn't look like it's in standard form because it's not. I know it's linear because I have a single variable x, and it's never trying to get funky and try to be x squared or x cubed or square root of x. No, no, no. And then the only other stuff I have there are constants for this minus 27. We'll see there's a constant come out of this. So it's generally, this is solving a linear equation. This is about on par with the level of difficulty you might see with one. So let's do this. Let me go ahead and solve this one with you. The first thing I would do is I would distribute the 3 here, and then over here I would combine like terms. Notice there's 3x plus 2x. That will become 5x minus, and then that minus 27 just has to be what it is. It's just got to stay there for the moment. Over here, I'm going to do 3 times 2 is 6, minus 3 times x, so minus 3x, and then that plus 4 is out there. So if you're trying to solve an equation and you see parentheses, the parentheses keep everything from being on like the same playing field, on the same ground. Because now this 2 minus x is not the same thing as this 27 or this 4 over here, because that 2 minus x has got a 3 that has to be dealt with first. So we have to use something like the distributive property in order to handle that. So the next thing I'm going to do is I'm going to combine like terms on the right. There's nothing with the x. The left isn't going to change. 6 minus 3x, but then plus 4, so 6 plus 4 is 10, and then I just have that minus 3x. All right, so now to continue solving this, I need all of my x's not to be in Texas, but to be on the left-hand side ideally. So I'm going to add 3x to both sides. I'm going to get 8x minus 27 equals 10. Now I've got this minus 27 bothering my x. Hey, is this guy bothering you? So I'm going to move it over. 8x equals 37. Then I divide both sides by 8 to get x completely by itself. So x is equal to 37 over 8. That's not going to simplify as a fraction, 37 over 8. So that's a good final answer for me. If you're supposed to express it as a decimal, you'll need to do 37 divided by 8. You'll need to literally do it. And so it goes into 37 4 times. Oops, that's a 2. Bring down this 0, line up the decimal points. 8 goes into 56 times. And it doesn't look like there's going to be a repeating pattern. So 8 goes into 22 times. Give it another 0, bring it down, and then 8 goes into 40 5 times cleanly, and there's not a remainder. So you're done. So your final answer could be 37.8, or it could be written as 4.625. So just read the problems carefully. That's going to be a great general tip that I can give you, is you want to read your problems very, very carefully. make sure you're like, oh yeah, I'm supposed to put the final answer as a fraction or round it as a decimal to 3 decimal points. Something like that. Let's look at another general concept that you're going to be tested over. So we solved a linear equation, and an equation has the equal signs there. Solving a linear inequality, and then graph the solution set. That's definitely something you might see. Now we in chapter 7, which we started last time, we started graphing things in 2 variables involving x's and y's, but that's not what we're doing here. We're solving just 1 variable things. And chapter 7 isn't even on exam 2 anyways. So maybe you're given a problem. Let's make it interesting. Let me think of something interesting in my head. Now, what we're going to do is we're instead of making that an equation, booyah, I've made that the greater than or equal to sign. The greater than or equal to sign, which suddenly makes this squarely an inequality. This is now an inequality. Now, the way you solve an inequality is awfully similar rather, to the way you solve an equation. But with one exception, if you multiply both sides of an inequality or divide both sides of an inequality by a negative number, you're allowed to do that. You just have to remember to flip your sign. It just straight up flips it and points it in the opposite direction. So, like I said, you usually want to distribute things. This is no exception. Now I'm distributing -2 to positive 9x. It becomes minus 18x. Greater than or equal. The right-hand side doesn't really change. Now combine your like terms. 4x minus 18x becomes -14x. There's still that minus 12 over there. Greater than or equal to 3 minus 2x. That's an x. Our goal is still to get out all the x's on the left-hand side in most cases, and this is one of them. So add 2x to both sides. You're going to get now -12x minus 12 greater than or equal to 3. Got to get rid of that 12 on the left-hand side to isolate x. So you're going to get 12x greater than, or excuse me, -12x greater than or equal to 15. Now let's zoom in on that. I'm going to have to move it a little bit over here so I can have more space. Now, I need to get x by itself. So what I'd normally want to do is I'd want to divide both sides by -12, and that's fine. That is totally something. That's exactly what we're going to do here. So divide both sides by -12. But we divided both sides by a negative. Flip your sign. So we had a greater than or equal to sign. It now has to become a less than or equal to sign. And then 15 over -12, that's clearly going to be a negative number. And then 15 over 12 reduces to 5 over 4. So now the solution is all x values less than -5 over 4. We can graph that on a number line. And since we only have one variable, it's just a single number line. You don't need to use the XY coordinate plane, which is technically two number lines, one of them kind of superimposed on the other. So it's negative 5/4. So maybe if 0 is right here, maybe negative 1 is over here. Negative 5/4 is negative 1.25. So it's a little bit, negative 1 is going to be over here. So, it's not to scale, but maybe negative 5/4 is right here. It's all values less than or equal to that. So you have two options. You can use a filled in circle, and then you can shade everything to the right of it, excuse me, to the left of it, because we want to go less than it. So just shady, shady. And you guys know the joke, and I hate the joke. The shading goes on down forever to the left. The joke I hate is remember to use real thick shading as opposed to real slim shading. I hate that joke, but I'm actually, there was a curse placed on me by a wizard, and blah, blah, blah. Long story short, I have to make that joke every time I do anything involving shading. It's not my fault. There's nothing I can do about it. That's just how life is sometimes. Sometimes you just have a curse placed on you, all right? Life's sometimes that simple. If this had been just a strict less than here, then what I would have done is I wouldn't have had a filled in circle, I would have had an open circle. If it was supposed to be greater than, I'd be shading to the right, not to the left. And then the filled in circle or open circle, it's a filled in circle if you have the or equal to. It's an open circle if you have a strict less than or a strict greater than. So that's kind of just a general overview. It doesn't seem like a lot, but it is, especially when you look at a lot of the different homework problems out there. So I think it's pretty straightforward. I think we have a good review here. Remember, all our lectures are available on the YouTube, including this review here. I'll be uploading it, right away here. It might take a few hours to physically show up on YouTube because they do quality checks and make sure, I don't know, that there's nothing wrong with the video. And then so you'll be able to access it later. Do you guys have any other questions about the exam? I think most of y'all would agree that the first exam was fairly straightforward for the material, especially if you've been staying up with it and studying really hard. I think the material was very straightforward, and I think you're going to feel the same way about the second exam here. So it's going to be a lot of basically solving linear equations and inequalities, a few word problems, but they're going to look a little bit more like the types of word problems that we've been doing in class. So unless you guys have any other questions for me, I think that's a good review for the exam here. Remember, we won't be meeting on Thursday. Won't be meeting Thursday at all because you'll just be taking your exam at some point on Thursday. So I wish you guys the best. Of course, you can always email me, message me in Canvas. I do check my messages pretty frequently. You've probably noticed that if you have messaged me. And check the YouTubes, check on the multimedia library for this course. You can find all kinds of videos. If you're working a homework problem, you can click help me solve this and you'll see that there's extra videos you can access that can help you. There's step by some, now I may not give it for that specific problem you're working on, but you can click a thing that says help me solve this and it'll give you like a step-by-step for a problem with the same type of problem with different numbers. So I think it's a pretty helpful process. You got some resources for you. Let me know if you guys need anything. We took attendance, and I hope you guys have a wonderful day. Thank you, Nicole. I appreciate it. Have a great day yourself. We'll see you guys next Tuesday, the 29th of September. We'll be meeting again. Thank you, Slater. And you guys, thank you. Have a great rest of your day as well, Madeline. Thank you guys so much. Always an honor, always a privilege. Y'all come back now, you hear? It's bad. It's a lame joke.